So good afternoon, everyone. Thank you all for being here today for our data analysis talk. We are a group of analysts from Goldman Sachs. As a tradition, Goldman will hold datathon events on a yearly basis. So the theme of 2020 is COVID. And as the winner group, we would like to present our work, a data analysis exercise to find the best and the worst performing stocks during the coronavirus pandemic. Next slide, please. So this pandemic has created a profound influence on the global society. And as a signal of the real world, we have seen an unprecedented behavior of the stock market after it reaches its highest point earlier in March. And there's clearly an underlying relationship between the market and the COVID-19 situations. And we want to develop an intuition behind it. So to simplify the problem, we use the number of the COVID-19 confirmed cases and the market data within S&P 500 as our data source to investigate the correlations between them. And then we perform a selection process to construct two stock baskets based on our analysis on single stocks that are from different sectors. So we totally construct two baskets. The one is expect to have the share price positively correlated with COVID situation, and another one is negatively correlated. And then we test our model and develop more thorough evaluations on the performance of the baskets. So on the bottom of that, we use Python and GSQuant, which is an open source Python toolkit that developed by GS for quantitative finance to build up this project. And the data processing framework that we set up is also a generic one that is capable of analyzing other scenarios with different models. So with that, I'll pass it to Luke.
So in this slide, as you can see, we built a complete framework, including data processing, calculating correlation, and data visualization. So first of all, this pipeline, our pipeline, will extract data from the COVID-19 database and the market database. For example, we choose new or total confirmed cases from the COVID-19 data. And we also choose the adjusted close price of the stocks in each sector from the SP 500 data in the market database. Then we feed them into a function to calculate their correlation. Based on the calculated correlation, we put some highly positively correlated stocks and highly negatively correlated stocks into separate baskets. We have performed some tests and examinations on these baskets, and moreover, we have data visualization among all of this work to display the result and then compare with other baskets. Although some of the functions actually has not been implemented yet, we leave the interface there, and the framework we have now is quite adaptable to further advanced work. And the next, Spencer will introduce you the implementation of our current work and the potential work in future.
So the actual implementation of this work ended up being a Jupyter notebook. If you're unfamiliar with this, Jupyter notebooks are a HTML web application that allows you to create documents that contain code, text, visualizations, and various other nifty things. We chose this because we already knew that we wanted to do our project in Python, and we wanted an environment that would make it easy for anyone on our team to be able to use, even if they did not have a full-fledged developer background in Python. And Jupyter notebooks have a heavy usage outside of those general engineering environments in like the data science sphere. So we all already knew how to use it. The notebook automatically pulls data from the constituents of the S&P 500, and it also pulls the daily new cases from the World Health Organization's COVID-19 data. And then it calculates the most highly correlated stocks, both positive and negative, in relation to those case increases over time, and returns the most highly positive and negative correlated stocks per GICS sector, which is the way that the S&P is subdivided into sectors like consumer discretionary and communication services and so on, as we can see in the charts on this page. So this is some of the example output of that notebook. And this, every time we run this on new data, it will return updated charts and updated rankings of those positively and negatively correlated stocks. So what we found from this was that the most highly, there were a lot of stocks that were very highly correlated with COVID-19 spread. The top 10 highest fell into 4 sectors: industrials, information technology, communication services, and consumer discretionary. And there were a couple of interesting things that we saw there. We saw that video game stocks in general did really, really well. You have NVIDIA, Take-Two Interactive, Activision Blizzard, that are all, large video game or technology related to video game companies. And then we had Amazon. And, if you think about it, these two make sense given the kind of global picture of what's going on here. You have a lot of people who are stuck at home and looking for different avenues of entertainment than they would usually follow. And you also have people who are trying to shift a lot of their purchasing to online so they don't have to risk, going to the store in person, which explains the Amazon's prominence there. On the other hand, we also found the highest negative correlations with COVID-19 spread. And something that was interesting that we found was that there weren't a whole lot of companies that were highly negatively correlated. If you can see here in this slide, the highest negative correlation that we have is 0.82, and these are all Pearson correlations. Whereas the highest correlation on the positive correlated stocks was 0.97, and the lowest was 0.92 over there. So for that reason, we only really chose 5 of the highest negatively correlated stocks, and those fell into utilities, consumer staples, and real estate, which real estate kind of makes sense given the shocks that are going through that market as people adjust to what the world may look like after the COVID-19 spread. And with that, I'll turn it over to Audie to go over the baskets that we created from these.
So we created baskets for the 10 positively correlated stocks and the 5 negatively correlated stocks that were mentioned earlier. And here we have plots of the of those 2 baskets, as well as the total number of confirmed cases. So the positively correlated basket, you can see, tracks the total number of cases pretty closely. And the negatively correlated basket is generally inverse to the number of cases, but this pattern is not as strong as it is for the positive basket. And this is expected based off of the previous slide where the negative correlations weren't as strong. Now I'll pass it over to Sylvia.
So before we look at the return of a basket, we actually did some exploration with other stock basket. So here we have S&P 500 and 2 other GS baskets that consist of stocks that could be affected by the COVID. And then we calculated their correlation and the year-to-date returns. So the reason why we use year-to-date return here is that the COVID data we choose, which is the total confirmed cases, is a cumulative one. So we want to use another cumulative measurement for return and therefore be aligned. So here we can see that of the 3 benchmarks we chose, The price of a lockdown basket has the highest correlation with number of total confirmed cases, which is about 0.95, and meaning that the year-to-date return has a really positively linear relationship with the total confirmed cases. And wherever the total confirmed case increases, it's likely to increase as well. And the return of the the price of the health risk basket has a real low correlation, which is about 0.2, and the market is somewhere in between. And on the second table, we also calculated the year-to-date return for those three baskets. And we can see that the lockdown basket also has the highest year-to-date return, which is about 0.7 or 47%, which is actually really impressive considering most of the stocks are actually decreasing during the COVID. And the market is about 4%, while the health risk basket is about 7%. So here we actually find the pattern that the closer the correlation is to 1 or -1, the more extreme return it will earn. So please go to the next page. And we have also calculated the correlation of our basket to the COVID data. And our positive basket has a really high correlation, about 0.974. And our negative basket has a correlation of -0.735. So we can see that our positive basket is actually more correlated than the lockdown basket. And our negative correlated basket has a correlation that is smaller than any of those baskets. And so we have an assumption based on the logic that we just saw that our positively correlated basket would potentially outperform all those three benchmarks that we chose, while our negatively correlated basket will underperform. And we decide to test this hypothesis with Ttest. So Ttest is a statistical method used to determine if there is a significant difference between the mean of two groups of data. And we use p-value here as a metric in the test. And it is basically the probability that the result from your sample data occurred by chance. So for p-value, we definitely want a low one because it will indicate that your data is not occurred by chance. So our null hypothesis here for the t-test, which is the hypothesis that we want to test against with, is that the year-to-date return of our basket does not significantly differ from that of the three benchmarks that we chose. And here, for a test on our positive baskets, all p-values are smaller than 0.01, which means we can reject the null hypothesis at a confidence level of 99% for these pairs. And our positive basket has a significantly larger year-to-date return than any of these benchmarks baskets. But however, for the negative basket, we see the p-value is smaller than 0.01 for the pair with the S&P 500 and the pair of the lockdown basket. So for these two pairs, we can also reject the null hypothesis and conclude that the returns of our negative basket are on average smaller than those two baskets. But we cannot reject the null hypothesis on the pair for our negative basket and the health risk basket. So which means that we cannot say that there is a significant difference between the return of our negative basket and the return for the health risk basket. So here we are trying to come up with an explanation on why this may happen. And the only thing we think is that the health risk basket, as what we saw in last slide, has a really low correlation to the COVID data. So which means it may not change a lot based on the COVID data. So so basically we cannot really tell from from the perspective of the COVID data that how it's going to change. Well, on the other hand, the negatively correlated basket actually negatively correlates with the COVID data. So it's quite reasonable that we cannot really compare the return for this two basket. Next slide, please. So we also tried to make an inference on the performance of our basket in the future by looking at how the correlation has changed. So here on the graphs in the left side, the blue line indicates the change of the correlation, while the red line indicates the change on the number of total confirmed cases. So here we can see that since mid-June, the blue line hasn't changed that much, meaning that the correlation of our basket to the number of total confirmed cases hasn't really changed. Although we are seeing a really fluctuating pattern on the change of total confirmed cases. So since here correlation is the only factor that we are looking at, and so when correlation doesn't change a lot, we can say that that our basket are expected to perform similarly as what we saw in the Ttest. Basically, our positive basket may continue outperforming the market, and the other two baskets, while the negative basket will underperform, or the relationship may not be very clear. And next, I will hand it over to Addie to introduce the trend of our baskets.
Yeah, so here we have a plot comparing our baskets to the GS lockdown basket and health risk basket. So the lockdown basket contains stocks that we expect to do well while people have to stay at home, while the health risk basket contains stocks that are vulnerable to global health issues such as the pandemic. So as you can see, our positive basket follows a pretty close trajectory to the lockdown basket. And by the beginning of September, which is when our analysis ends, our basket had about a 6% greater year-to-date return, but throughout the whole time period, the returns were never too far off of each other. And our negative basket follows the same general trend as the health risk basket up to about June, at which point the GS basket starts to increase in returns, while our basket continued to decline in return as the number of cases went up throughout the summer. So the diversion in these two negatively correlated baskets is interesting, and it could be investigated further. There may be differences between the companies that continued to decrease in returns throughout the summer and those which started to increase even as the cases started to increase or continue to increase in the summer. So understanding why different companies perform differently during major events, such as a pandemic, could help investors make better decisions if similar such like crises occur in the future. And doing that sort of company by company analysis would be a further step to see if there's anything in common between those that started to do well partway through and those that continued to not do well. And to conclude, I'll pass it back over to Spencer.
So admittedly, Pearson correlation is not rocket science. It's a pretty simple measure of comparing these two indices, but it did give us some valuable insights as to what groups of companies were the most affected by the pandemic and give us potential opportunities to like hedge against risk in the market according to those companies. In the future, we would like to take this framework and possibly apply more advanced models to it, machine learning or artificial intelligence, to see if we can track to see if we can build a basket that tracks COVID spread even better than the one that we have currently. And also so that we may be able to find connections to industries that we may have missed with this more simple analysis. But with that, we have some time for questions.
I saw some questions in the Slack channel.
Yeah, well, one of the questions is, what is the mobility bullet in the COVID-19 data? So the mobility data that we had access to was provided by Google, and it was looking at location data of people throughout the pandemic. So it was looking at how much, what percent change in people were at residential areas or stores or at parks, and it was divided by different categories. So you could see as the people's mobility changed, if that would, we could have done analysis using if the mobility changes to stock prices. For this project, we only looked at the actual number of cases, but that mobility data was also available to us.
I saw the question that how is Zoom not on the list? Because Zoom is not in SP500, so that's why it's not on the list. We never checked the correlation between them.
Yeah, I think that a further analysis of companies outside the S&P 500 would be interesting. But actually gathering all of those data points turned out it's surprisingly harder than you would expect, just given the way that financial data is organized and presented, and how there are multiple different providers of those data. So we stuck with the S&P 500 for ease of use, but had we included companies like Zoom in here, I think that we would see a significant rise.
Then another question was, why does the confirmed cases change plot look like that? I think if you go back.
Is it, I think they're probably referring to this one.
Yeah.
So this pattern is that it's because like how different states in this here in the US collect the total number of confirmed cases. So like the data we used is the total confirmed cases in the US, which is like the sum of all total confirmed cases within each state. And then for some state, they would they would disclose their data on weekends, but some do not. So that's why basically you will have a peak usually on Monday, is that some state will just disclose all their data on the weekend on Monday.
Yeah, those are all the questions on Slack.
Cool.
Were there Anita, if she had any questions from Slido?
It sounds like probably not. And I'm not sure how to access those if we do have any. Of course, if there are any questions on this presentation, feel free to share them in the more general Slack channels for the conference. You can feel free to mention any of us who were involved in this talk, and we'd be happy to, give a response virtually there. So
I think we have one more in Slack. Yeah, I've heard that smaller businesses were more likely to be affected negatively than larger ones. So it does seem like it might be interesting to go further than the S&P 500 for analysis, especially on the negative side.
it would be interesting. I think that And I think that a lot of those aren't going to be captured in the stock market either. Because this is just me and my opinions, but from where I live, the places that are being hit the hardest are, restaurants and coffee shops and gyms and places that, you're not going to see your local coffee shop on the it being traded on the New York Stock Exchange. So it would be interesting to figure out how to measure that kind of an impact, because the stock data for a lot of those, I think, doesn't really exist. I don't know.
Yeah, just to add on that, I think the cool thing about this project is that it really provided you a framework to access all those data and then perform the analysis after that. So for example, if we replace the S&P 500 data with the small business data, if we are able to access them, then this framework would also produce the results based on new data pools.
Yeah, like bankruptcy data, things like that. Those would definitely be useful. And so, instead of looking at just stock prices and these more, I guess, economic factors, can better model certain individual communities. When there isn't actually a, it's not on a publicly traded exchange.
Cool. Was there anything else you guys can see on the Slack?
No, that was all.
Cool.
That's all we really had.
All right. Well, thanks again, everybody, for watching. And again, feel free to message us in the Slack if you want to know more.